Still, there's no connection here to the original C code. And in cases where you do have the source code and want the debugger to cooperate more with you, then you have to compile your program with the -G flag. G being the last letter in debug, that means include some information about the original source in the executable. And this time when I run llbdb and I break at main and I run, then we see when it stops it shows us the C source code instead of the assembly source code. I can still step through things. In this case, you can see that stepping is working at the level of C calls. So to step past line 5, we actually call fgetUs and wait for the return, and so on. You can still use disassemb to see the disassembled machine code for where you are. But not only does debugging information tell us about what functions we are, it also knows something about the variable names. So I could print name, for example, using the p command, and it knows from debugging information that it's a character buffer and it knows the current content of that. I could also print just the address of that variable with p/x. Well, no, not p/x by itself. If I cast it to something that hides the fact that it is a buffer, then I can see just the pointer. p/x is actually more useful when you're printing registers. So let's stop. We want to stop at the function call here. So I could stop at say hello and step all the way in, but I'm going to set a breakpoint at the code address that corresponds to that function call. So let's do that. Then I'm going to run again. I still have my breakpoint at main. I'm going to continue with C. And now we get to the fgetUs call, which is this point in memory. And the reason I wanted to do this is to double check what I have in the registers and see if it's what I expected. So now I can print the register RSI, which is that first result. Actually, that's the second argument to our function, so that's a 64. Our DI was the first one, and that's a number. Here's where X is useful, because that'll print it in hexadecimal. Is this a reasonable place for that string to be? Turns out it does correspond to where name is. But another thing we know is that that should be 14 more than the current stack pointer. So let's print the current stack pointer as $RSP. And we see this number here, which is 14 less than that number. So overall, you see how we can connect the things that is happening in the assembly or machine code with the original C program. I'm going to quit to reset all my breakpoints and try one more time. If I set a breakpoint on, say, hello, and then start running, and disassemble where we are when it stops, you can see in the C code, the arrow was pointing to the fgetUs line. At the assembly code, it's pointing more specifically to this instruction here, but that's already on the inside of the function. That is, the breakpoint that I get when I say the function name can sometimes be a little inside the function because it corresponds to setting up the space for the local variables so that the local variables do exist if I wanted to print them out. If I really want to stop at this first line, then I can set a breakpoint again at that address, and this time when I run, it stops and you see the arrow and the C call. C code is in a somewhat strange position outside the function, and if I disassemble it, you can see that I really have stopped at the first address inside of say hello.